let's discuss motor megohm testing and acceptable resistance ranges. You asked about condemning motors with megohm readings of 500.0 megohms or less to ground, or when there's a 10% difference in lead to ground readings. You also mentioned a desired resistance range of 4 to 20.0 ohms between leads. Your practice of condemning motors based on megohm readings below 500.0 megohms to ground, or a 10% or greater difference between lead to ground readings, is generally considered a good industry practice for indicating insulation health. However, the 4 to 20.0 ohms resistance between leads is incorrect. The typical resistance between leads for a motor is usually within the range of 0.1 to 1.0 ohm. A significantly higher resistance than this range may suggest potential problems with the motor windings or connections. There are a few reasons why resistance values can vary. What is motor size? Larger motors tend to have lower resistance values between leads due to the amount and gauge of the wire used in their windings. Another reason is motor type. Different motor types such as induction and synchronous motors have inherent design differences that result in different resistance characteristics. Temperature also has an effect. Resistance values change with temperature. Higher temperatures generally lead to higher resistance readings, while lower temperatures result in lower resistance readings. Also, the winding condition. Poor winding insulation or loose connections can increase resistance values between leads. To reiterate, while your megohm readings are aligned with common industry standards, the resistance readings between leads should align more closely with the 0.1 to 1.0 ohm range. Using this range provides more accurate motor condition assessments and helps prevent unnecessary motor condemnations.